Hey class, I'm here to show you the demo of the lab that you're going to do today, or maybe you missed it and you want to, live the good life and watch what we did in class. So you're doing an acid-base titration today. That's when you take the known concentration of a base, you add it into an acid of unknown concentration to figure out what is the molarity of the acid. Okay, in this case, we are using 0.2 moles per liter solution of sodium hydroxide, also called 0.2 molar, right? And our unknown acid is actually just vinegar. So we're trying to figure out the concentration of acetic acid in vinegar. So that's the active acid in vinegar. So I've already started to prep things for you, but I'm going to show you more because the prep gets a little confusing. This piece of glassware right there, very fragile. It's called a burette. This is a 50 milliliter burette. The markings start on top and go to the bottom. So you actually, as you add the solution, right, you'll see the volume increase. So you might want to think about, why do the numbers go from small to large going down? What are we measuring there? All right. When the stopcock right here is horizontal, so parallel with the table but horizontal to the perpendicular to the actual burette, that means it's closed. When it is pointed down, that means it's open and solution will run freely through there. So before you add any solutions, you want to make sure it is fully closed. Okay, so I've already prepared my Erlenmeyer flask right there with my acid solution. So it's got the 10 milliliters of acetic acid of the vinegar, 25 milliliters of water. So the acetic acid, distilled water, right? We don't want tap water, that's slightly basic. And about 5 drops of phenolphthalein, which is a basic indicator. So it'll turn colors once you cross over that neutral to basic point, right? As you add in the base, you get more basic, a higher pH. So I've already got that in there along with a stir bar to stir it. The water is really just to add more volume there so you can visualize it better. All right, I need to now prepare my burette. This has already been pre-rinsed with distilled water. It's been rinsed with the solution, so it should be ready to go for you, okay? What I need to do, and you can follow along with the procedure sheet, right? I'm going to add the sodium hydroxide, the 0.2 moles per liter sodium hydroxide, until I get just past that 0 mark. All right, I want to get just past it because I want to drop it down to 0 because it's very hard to get it perfect, as well as I want the solution to drain through the tip. So I know that's all just sodium hydroxide. So I'm going to pour this slowly because sometimes it kind of gets stuck in the funnel. And then you can overflow, which I have most definitely done. So I have that filled. Can't really see it, but it's just above the last mark there, which is the 0 mark. All right, I'm going to flip this around so I can see the graduations there. And I'm going to look at eye level, and I'm going to drop the bottom of that meniscus. So slowly I'm going to open it up. Okay, I see it dropping slowly until I see the bottom of that meniscus, that dip, line up perfectly at 0, right? If you overshoot, that's okay. Just add more and drain out more. Down here, I have a waste beaker. I do not have my Erlenmeyer flask because I don't want the reaction happening yet. So this is just a beaker. It can really be any size. I think I say 150 milliliters. It really doesn't matter the size, okay? So I can set that aside because I am ready to go. So I'm gonna put my Erlenmeyer flask on here. I'm going to raise this a little bit, which I can do just by sliding it up and down. I'm going to put my Erlenmeyer flask under here, and I'm going to drop this down in there. I want the tip, close to 1 inch underneath the lip of the Erlenmeyer flask, if you can see that there. It's right about there. And in the center, I don't want it touching the sides. I don't want extra solution splashing up or spreading on the sides because I want that all to react. So I'm going to turn this on, not stir plate, right? And I'm going to get it to a decent speed where it's spinning well, but it's not splashing anywhere. All right, I'm now going to start adding my solution, okay? Normally, you wouldn't know where to add to. In this case, I give you a heads up because it takes a while to get most of that solution down. So I tell you in the procedure that you can add pretty rapidly until 35 milliliters. So I'm going to do that. The more vertical, like parallel with the burette, the stopcock, the faster it'll drip. Okay, so to start with, I'm going to add it kind of fast to drain it down. And I'm watching it carefully. I'm getting ready to stop it when I need to. All right, so I'm going to go to 35 milliliters because I know the molarity, right? You don't know it yet, but you will. And I know it requires over 35 milliliters. All right, I'm going to shut it off. And I'm going to move it closer to you, so hopefully you can see that color change a little better. Let me adjust the camera. All right, so let's see if you can see that. So what you're going to notice is the phenolphthalein turns colors as soon as you get to a basic point. So as soon as you get above 7, typically around pH 8, you'll see it turn colors. Once it turns a certain shade of pink and stays that color, you've reached the end point. If you go too far, your pink will be too bright. If you stop too early, the pink will disappear. Okay? So I'm going to just start adding little by little. And I have choices. I can either let it drip in slowly, drop by drop, or I can add a little bit, as you can see that pink coming up there. Add a little bit at a time and then stop. Okay, adding a little bit, seeing that pink still disappear and then stopping. Okay, but it happens really suddenly. So this is a pretty technical lab. It can be hard to get it spot on that endpoint. All right, we're back and we're really close to that endpoint. Okay, super close. Because what I'm noticing, which you'll see here too, is as I just barely let any drop in, you'll see that pink kind of last a little bit longer. Okay. Once I get a pink color to stay there for at least 30 seconds, and you notice I'm using my hands on that stopcock to go back and forth to just add a drop or two at a time. And you can definitely leave it open so just one drop at a time is going in there. And I'm not going to tell you what volume I'm at. If you weren't here for this lab, I give you some sample data. But if you were, you got to figure it out, or if you're about to do the lab. Right. All right, class, there you have it. That is that perfect shade of pink. That's just the point where the pink has appeared and stayed, but it's not super bright. You do not want a pink like this color, okay? I will show you what that looks like here in a sec. To help visualize this, right, you can slide, I forgot to say this earlier, a white piece of paper underneath your flask. And sometimes that helps you see the color difference, like, is that pink, is that not pink? So there you go. That would be about the perfect shade that you want, just very slightly pink. So that's the end point. So I would then look, where is the bottom of my meniscus? And I'd mark down that volume. That is my volume of base added. I need to convert that to liters, right? Whenever you're doing molarity calculations. So if I let it go too long, whoa, okay. If you show me a beaker, a flask like that, an Erlenmeyer like that, I'm going to say, okay, you got to redo it. Sorry, because you are way past that endpoint. But it's a beautiful color. All right, it was a fun lab. I'm going to enjoy doing it with the rest of you. And that's it for now.